Okay, well, welcome to Section 1, Part 2. We're going to be talking about mainly application problems here. Okay, growth and decay. Still working, though, with integer exponents. No fraction exponents yet. I won't hit you with that till Section 2. Okay, application problem. Let's say that you have some bank account, and the principal, that is the money that you have, is $100, and the interest rate is 5%. Well, your interest is equal to your principal times your rate. So in this case, it'd be $100, the P, the principal, times the interest rate, which we don't write as 5%, we write as 0.05. We put it in decimal form. Okay, that's R. And so it's $5. That means you get $5, say, after 1 year. Well, another way to think about it is this. Take the $100 plus $100 times the interest rate, which means you would have, after 1 year, $105. Well, that's easy enough. $100 at 5% interest for 1 year, $105. Or you could factor out that 100 and make it 100 on the outside, which leaves you with 1 plus 0.05 to the first power. After 2 years, it'd be 1 plus 0.05 to the second power. Excuse me. After 3 years, 100 times 1 plus 0.05 to the third power. After n years, it just works like this. It's the same formula. In general, your formula for growth, for exponential growth, is take your initial amount, whatever it is, that's this A naught or A sub 0. That's your initial amount times the quantity, 1 plus the rate of interest. But the 1 plus the rate of interest is raised to the power of how long you're interested in. Okay? And similarly, for decay, instead of plus the rate, you subtract the rate. That will always give you whatever your new amount is. So, for instance, let's do a couple simple examples here. Say you have some cars. Now, cars usually decay in value. They go down in value over time. That's why we call this a depreciation rate as opposed to an appreciation rate. Find a formula for n years. So just find a generic formula. Now remember, our formula was this. A of n, I'm going to use n instead of t here, equals the initial amount times 1 minus the rate to the nth power, the number of years or whatever it might be. Okay, well, what is our initial amount? Oh, well, I told you it's $30,000, so that'd be $30,000 times 1 minus, what's the rate of depreciation? 10%? That's 0.1. That means R is 0.1. To the nth year, because they didn't tell us how many years. Well, that really just means 30,000 times 1 minus 0.1, that's 0.9 to the nth year. And there you go. That's your formula that will tell you how much the car is worth after n years. Well, find the value of the car after 6 years. That means just take this 6. Let's find the amount the car is worth after 6 years. That means plug in 6, evaluate the function at 6 years. And then you just type that into your calculator. If you want to do it one step at a time, be sure that you're doing 0.9 to the 6th power first, because order of operations says exponents come first. Round it to the nearest penny, since we work in dollars and pennies. And it's about, $15,000, 943 and 23 cents, something like that. And type that in your calculator to confirm my work. You're going to need your calculator for this section if you haven't figured that out by now. Okay, let's do another example. Now, the value of a car t years from now is given by this formula. So I've given you the formula. That's interesting. What is the annual rate of depreciation? How much does it depress? Now, note here, that usually the formula looks like this. V of t equals V naught, the original amount, times 1 minus R to the t power. But the 1 minus R in this problem is actually equivalent to 0.75. Oh, wait a minute. 1 minus R, that's really 1 minus what gives you 0.75? 1 minus R gives you 0.75. Well, that just means R is 0.25. So which one's the rate of depreciation? Is it the 0.75? Or is it the 0.25? You got it, it's the 0.25. So it actually depresses 25% each year. So it's about a 25%. Let's write it as a percent. rate of depreciation. Or you may write depreciation rate if you'd like. Depreciation rate. Now, in how many years will the car be worth half of what it is now? Oh, I love these questions. This is what Chapter 5 is all about. In how many years will the car be worth half of what it is now? Well, let's see here. How do we do this one? Well, there's two ways you can do this one. First off, you can do method 1, where you just kind of guess. Now, here's your formula. Always start with your formula. When you don't know what else to do, go back to the formula. 1 minus r to the t power. Or, oh, in this case, n power, not t. All right. Well, let's see here. Do I know what the initial value is? Do I know what the initial value is? Oh, I do. It starts out at 25,000. So I'll put that there, 25,000. 1 minus r. Oh, they gave me that. It's 0.75. And it's right, but I don't know n. That's what I'm looking for. N is my question mark here. I'm going to put that. N is my question mark. But wait a minute. They want to know when it'll be worth half. Well, what's half of the original value? What's half? Remember, the original value was 25,000. I'm going to write that right there. I want to know A of n, though. Well, it's going to be half of what it started out of. Half of 25,000. Well, that's just 12,500. Oh, that's the value I'm interested in. I'll put that right there. I want to know when the answer will be 12,500. Okay, well, now I'm in business. Now I can kind of solve this. All right, we'll get n by itself. Let's figure this out. Oh, why have I been using n? It's actually supposed to be t. That's my bad. Regardless, n or t, doesn't matter. Well, divide by 25,000. 12,000 divided by 25,000, that's just 0.5. That's just 1/2. And now you got to solve this. You got to solve this. What value of n would make this true, or what value of t? So the question is, I'll just keep using n. Can n equal 1? Well, if n equals 1, then you get 0.75 equals 0.5. Well, that's silly. All right, can n equal 2? Well, 0.75 to the second power. Let's see here. That's about, type that in, it's about 0.56. Well, is that equal to 0.5? No. Okay, but can n equal 3? Well, that'd be 0.75 to the third power. That's about 0.42. Wait a minute, that doesn't give me 0.5 either, so that's no. But when n was 2 years, after 2 years, it was worth, n was 0.56. After 3 years, n was 0.42. But I want it to be I want to end up with 0.5. So what happened here? It's got to be somewhere between what and what? It's got to be between how many years? It's got to be between 2 and 3 years. Somewhere in that range, the car will be worth half of what it is now. Half of what it is now. Okay. Now, here's method 2, and this is probably the one I like a little bit better. It's just the book doesn't show you this till later, but it's logarithms. So set up the same formula. What was your initial amount? 25,000. And what is our interested amount? We're interested in when it's worth half of what it started out as. So put 12,500 over here as the answer. And it depreciates at a rate of 75%. I'll use t this time. So you solve for t similarly. You just divide by 25,000, you get 0.5. Raise it to the t power. Now, instead of just guessing, you're going to solve this using logarithms, and this is what you do. And if this confuses you, don't worry. It's not technically not till later on in the chapter. You take the t and you throw it out front. But to do that, you turn the little t into a big T. You have to take a logarithm of both sides, and you may not even know what a logarithm is yet, and that's okay, as long as you know where the button is on your calculator. Now, the logarithm is just some number. So what you do is you get t by itself by dividing by the log of 0.75. The log of 0.75. And now you literally just type this into your calculator. You just type this into your calculator. So I'll show you how to do that. So here's my calculator. And what did we want to do? We wanted to do the log. Where's log on these calculators? I don't see log. I don't see log. Where is log? Where is log for real? Oh, there it is, right there in front of me. Log, sorry guys, of 0.5, close your parenthesis, divided by the log of 0.75. And boom, that's what t is. So t is actually about 2.4 years, or 2.41 years. And by the way, that lines up with our guess that we had earlier. So t is about 2.41 years, and we said that it would take between 2 and 3 years, and we were right, about 2.41 years. Okay, that's all the application problems I'm going to do for section 1. So work hard, and I will catch you guys later. Talk to you later. I'm out.